Okay, and we're back, people. Quiet down, please. So yesterday we talked about, well, I guess yesterday and the day before, we talked about generics of the slope value, right? Can somebody tell me what slope is? Somebody raise your hand and tell me, what is slope? Liam.
How higher rise up something?
Good. How much something rises and runs. Should the slope ever change?
No.
No. The slope should never change no matter which point you pick. The slope is a measurement of the steepness of the line. Could be positive, could be negative, could be zero, could be undefined. So we learned a lot about the general value of slope. Okay? What we're going to look at today is more the math behind it. Okay? Why the slope value is what it is. In lesson 5.3, we described the constant rate of change of a line as slope. Okay? And we talked about slope based on the graph. We said, okay, look at the rise, look at the run, blah, blah, blah. Now, there's also a formula that you can use to find the slope of a line. This is more on the numbers side. If you didn't just want to find, okay, how many points did I move up? How many points did I move over? If you didn't really want to do that, or if you couldn't do that, if you weren't given a graph, if you were just given coordinates, you could use this formula. Everybody, box, highlight, circle, star, whatever you need to do that formula, memorize that formula. Memorize that formula. That's a formula that I will not give you on a test or quiz, that you must know.
We did this last year.
Good. y2 minus y1 over x2 minus x1. It's the difference in the y's divided by the difference in the x's. Okay. So find the slope of a line that contains the following 2 points. Now, it doesn't matter which one you call x1, y1, which one you call x2, y2. You just have to keep them organized. Here's what I mean by that. The slope is going to be the difference in the y coordinates. So let's go from the second coordinate to the first. 1 minus 5 divided by 8 minus 2. Always write it out. Always write it out, because chances are if you try to skip steps, you'll drop a negative somewhere along the way. So that means 1 minus 5 is negative 4. 8 minus 2 is 6. Can I leave it like that? What do I have to do to that fraction? Simplify it. Negative 4 over 6, they both have a common factor of 2. Divide out of 2, negative 2/3. That's my slope. Okay, that's the slope formula, right? Difference in the y's divided by difference in the x's. Remember, you're always taking y divided by x. Y divided by x. Let's do another one for practice. 5 negative 7, 6 negative 4. Go ahead and try to set it up for yourself. Set it up for yourself. Okay, to set this up, I would say my slope value, m, is equal to negative 4 minus a negative 7. Be careful. Minus a negative. And then we have 6 minus 5. Now, negative 4 minus a negative 7. People, if you have to, just use your calculator. Negative 4 minus a negative 7. Positive 3. Divided by what? 1. Now, could I give a slope as 3 over 1? That would be okay. Would you want to just make it 3? Sure. Either way, don't care. Questions about that? Now, so we've seen an example as a fraction, negative slope, positive slope. Are slopes always either just positive or negative? Sometimes it's 0, sometimes it's undefined. So what's that going to look like in terms of our formula here? Well, take a look at these 2 coordinates. if I wanted to apply the formula, I would say -2 minus a -2 divided by 7 minus a -2. Everybody following me there? -2 minus a -2, 7 minus -2. Well, what's -2 minus a -2? 0. What's 7 minus a -2? 9. So that would turn into 7 plus 2, right? Minus negative is plus positive. That would turn into 7 plus 2, or 9. What is 0 divided by 9? 0. So my slope is 0. What does that mean about that line?
Straight.
All lines are straight.
Horizontal.
It's horizontal. It's horizontal, right? Okay. So let's do this next one. The slope would now be -6 minus a -3 divided by -5 minus a -5. Notice how I've got the same number in my x coordinates? So now I say -6 plus 3 is -3. Now I have a 0 in the bottom, which is now undefined. So what does that tell me about this line? It's vertical. I thought you were going to say it's straight. It's vertical. It's vertical. Does that make sense? Okay, so that's if I'm given 2 coordinates, just plugging it straight into the formula. Sometimes we're not given 2 coordinates. Sometimes we might have a table or a graph. Like, for example, this one. This is very, very, very similar to the ones that we started doing in chapter 5. The table shows a linear relationship. Find the slope. Okay, if we've got a table, what's the amount of change in my x values? What's the amount of change in my y values? What's my slope? Be careful. What's my slope? Ready? -2 over 1. Slope is -2 over 1. Rise 2, run 1, and it's negative. -2 divided by 1. Make sure you do change in y divided by change in x. Not change in x over change in y. Okay. Okay, so what if I'm given a graph? We're on the back page. What if I'm given a graph? The graph shows the average electricity cost for operating a refrigerator for several months. User error. The graph shows the average electricity cost for operating a refrigerator for several months. Find the slope of the line and tell what the slope represents. Man, have we been seeing a pattern to all of these word problems? Every time I ask you to find a value, I ask you to tell me what it represents. Okay, you'll see that as a trend here. Okay, so what is the slope of this line? I knew you were going to say that. Oh, both of those are wrong. All of that is wrong. People, why can't I count the boxes?
Oh, they're going up by different.
They're not going up by ones. They're not going up by ones. They're going up by different intervals. You can't use the graph when they're not standard intervals. Okay, so that means I need to use the formula. 24 minus 12. Y minus y over, so if I use 24 first, I've got to use 4 first. 4 minus 2. Follow me there? You did 12 minus 24? That's okay. Did you do 2 minus 4 on the bottom? That's okay. You're good then. So we have 12 over 2. Did you get positive 6 as your slope? Now, what does that represent? 6. What does that value represent? It's the slope, but what is the slope?
The time and the color.
It's a combination of the two, right? It's a combination of cost and time. Remember, you can always think about slope as change in the dependent variable versus change in the independent variable. Change in y values, money per time, right? Money per, actually it's month, right? So what is that telling me? 6 what? $6 for every, if I were to truly write this as a fraction, $6 for every 1 month. $6 per month. That's the rate of change. That's the price per month. Okay? If you need to, set this up with the labels. Slope should always be the change in y divided by change in x. So it's change in money divided by change in time. So if this is 6 over 1, this is $6 every 1 month, changing $6 per month. Okay. If you know the equation that describes a line, you can find its slope pretty easily by using 2 ordered pairs. But they just have to be strategically picked ordered pairs. Like, for example, here. What's the easiest, what are the easiest points to find?
The X and the Y.
The X and the Y intercept, right? Especially because what form is it in? This is in standard form. And we just did this on the warm-up. Let's find the 2 coordinates. So that gives me 4x equals 16. So x is 4 comma 0. This gives me negative 2y is 16. Divided by negative 2, y is negative 8. 0 comma negative 8. Now I can find the slope pretty easily. Especially because these are zeros. You got to be careful. Negative 8 minus 0. 0 minus 4. Just be careful when you order them. Negative 8 minus 0 over 0 minus 4. Negative 8 minus 0 is negative 8. 0 minus 4 is negative 4. So it's positive 2. That's the slope. So it's taking one additional step past finding the intercept. You're not only finding the intercept, but you're now finding the intercept and then using the slope formula upon it. Let's do one more of those. Okay, is this one in standard form? No, let's put it into standard form though. Okay, now, just like the one on the warm-up, hold on everybody, hold on. Just like the one on the warm-up, what's the easiest route to take to put this into standard form? Okay. Add the 2x. I'm just going to add this 2x because I've just got to get the x and y on the same side. So this is 12 is equal to x comes first, y comes second. If I really wanted to visually see x and y on the left side, I say 2x plus 3, because I like that. I will do that every time. 2x plus 3y is equal to 12. Flip everything on either side. And now it's in standard form. Find the intercepts. 2x is 12. So x is 6. 6 comma 0. 3y is 12. So y is 4. 0, comma 4. And now I can pretty easily find the intercepts. Or sorry, find the slope, excuse me, find the slope. So my slope would be, come on, green. There we go. Slope is 4 minus 0 over 0 minus 6. You follow me there? 4 minus 0, 0 minus 6. 4 minus 0 is 4. 0 minus 6 is negative 6. What's that turn into? Mackenzie?
Maybe Q2.
Good. Feel good about that?
We have a worksheet for homework? Yeah.
Wait, why would you put the 4 on top? Oh, 4.
Y values go on top. Yeah, better to come in. Yes, we'll do on Monday. There you go. There you go. There you go.
And that is when it's going to come for a week for like approximately 5 years for actually the hair.
There you go. Yeah, it's 2 sections. But again, the slope stuff should go pretty quickly. I'd like you to work on it for a couple minutes so we got here.
Do I need to convert everything? Like, page 2 over 3, I need to convert that anything?
No. The only time you would ever need to make it a decimal, you're talking about making it a decimal? If it's a word problem. Okay, come on, I want you to start working on this. It's just a worksheet. You can probably get within the first couple minutes at least the first 5 done. And that should be pretty easy. If not, the first whole page, because those are just using the slope formula down there. I know it's only a couple minutes, but you can get a good head start on it. So long, everybody at home.